Okay, so right now we have discovered that there's two ways that we can talk about how steep this line is. Um, we can talk about it by this angle right here, saying sort of how much our line has moved from horizontal. So the larger the movement from the horizontal, the steeper the line. So that's the angle that's used to measure that. Or we could measure the rise over the run. And then we found out that we have this convenient function called tangent, which converts one to the other. So you can either say, hey, my line is going up at 18.4 degrees, or you can say, my line is going up with a slope of 1/3. Okay, so you can move back and forth between these two things. So here I've written down, we know that our triangle goes up 1 every time we're over 2. So let's go over 2, up 1. That just gives a rough idea. So that kind of angle right here. And if we want to find the angle, but we know the slope, then we use the inverse tan. So theta is equal to the inverse tan of the rise over the run, or the slope. So theta is equal to the inverse tan of 1/2. Okay, so we'll just pull up the calculator, clear this, inverse tan, 0.5, because that's what 1/2 is. And that works out to 26.6 degrees. So we'll just fill that in our little chart here. So now we have 26.6 degrees. An increase in the angle has caused a steeper line, which has a higher slope. Let's just write these in decimal form. So this is 0.333 repeating. We'll just put 0.33. And this one here is 0.5. So increasing angle, increasing slope. Okay, so now 30 degrees is an angle that shows up a lot. So what we're interested in here is finding out what kind of slope a 30-degree angle has. So tan of the angle gives us the slope. So tan of 30 is equal to, let's go over here, clear this, tan of 30 is equal to 0.58. We'll round it to, so 0.58. So here, this is going to be 0.58. So this tells us that if I increase my, let's write this in here, if I increase my angle to 30 degrees, something like that, then O over A is going to be 0.58 to 1. Okay, so the ratio of these two sides is 0.58 to 1. Okay, we already saw 45-degree angle is a isosceles triangle, so it has a 1-to-1 rise over run. 1 over 1 is 1. Okay, and then here's another one. Maybe we're interested, what if we go up at an angle of 60 degrees? So something more like this, 60 degrees. Now, what is our rise over run, or O over A? So we need to know tan of 60 to get the O over A, which is the slope. So we'll take our calculator, take the tan of 60, 1.7. So we're just filling in this chart. So 1.7. So this side here is 1.7 times bigger than that side there. So 1.7 to 1. Okay, what if I have a triangle where the rise is twice as big as the run? So that means the rise over run is 2. 2 or 1 or 2. So that's equal to my slope. So if I want the angle, I'm going to take the inverse tan of my slope and see what I get. Inverse tan, oops, let's clear that. Inverse tan of 2, 63.4 degrees. Okay, so 63.4. And finally, what if I have a 3, looks just like a 2 to 1, okay. 63.4. What if I have a 1, and then this is 3 times as big? What's this angle here now? So I have to do inverse tan of 3 instead of 2. Clear, inverse tan 3, 71.6 degrees. 71.6. These are all measured in degrees right now. That's the angle measurement we're working with. Okay, so let's make some observations here. Basically, at 45 degrees is the rise and the run are the same. Okay, if the rise becomes bigger than the run, then you would have a larger than 45 degrees. So now the rise is larger than the run. So if the slope is greater than 1, then the angle is bigger than 45. And a similar observation here, if your slope is less than 1, then the angle is less than 45 degrees. Okay, and here, like a big increase in slope and not such a big increase in angle. So definitely non-linear relationship.